Good morning guys. So we discussed about the chapter some basic concept and its problems. Now we are going to deal with the important topic of the some basic concept, that is limiting reagent and the stochiometry. What is mean by limiting reagent and what is mean by stochiometry? For example, if you have 2000 steerings, then 1000 brakes and 500 engines, what will be the limiting reagent of forming 500 vehicles? That's a question. The limiting reagent of forming 500 vehicle, the limiting reagent will be act as 500, which is firstly primarily consumed fully in a chemical reaction. That is the 500 engines needed for the 500 vehicles. So even though the steering is 2000, so it for making 500 vehicles we not need only 500 steerings, so balance will be 1500. In the case of brakes, there is 1000 brakes, we need only 500, so the excess is 500. So which is primarily fully consumed in a chemical reaction is known as the limiting reagent. This is known as what is mean by limiting reagent. Limiting reagent is a substance that completely consumed in a chemical reaction is known as a limiting reagent. What is mean by limiting reagent? It is a substance which completely consumed in a chemical reaction is known as the limiting reagent. Now we are going to what is mean by stochiometry. If you are calculating in an equation, that is it have a reactant and it have a product, both which have a reactant and it have a product, we are calculating the mass of both reactant and product in a balanced chemical reaction is known as the stochiometry. The balancing of a chemical reaction by equating the mass on the both the side is known as a stochiometry. Let us go through that. Balancing of a chemical reaction by calculating the mass of both reactant and product involved in a chemical reaction is known as the stochiometry. So what is meant by limiting reagent? The substance that completely consumed in a chemical reaction is known as limiting reagent. And what is meant by stochiometry? Balancing of a chemical reaction by calculating the mass of both reactant and product in a that involved in a chemical reaction is known as the stochiometry. Let us go to some tricks to do the problem of limiting reagent and stochiometry. For example, if this is a question, 5 mole of A react with 20 moles of B, calculate the number of moles formed by C in the reaction A plus 2B equal to C. If this is a question, the question is A plus 2B is equal to C. It is 5 moles of A. This is very important. That is 5 moles of A react with the 20 moles of B in the reaction, that is A plus 2B is equal to C. So I am writing this equation, that is A plus 2B equal to C. The number of moles in this question, that is here it is 5, here it is 20, and the stochiometry coefficient, what is the stochiometry coefficient here? Here 1, here 2 is the coefficient, and here also 1 is the coefficient. I am writing the stochiometry coefficient. Then what I do, number of moles divided by the stochiometry coefficient, that is 5 divided by 1, number of moles divided by stochiometry coefficient, that is 5 divided by 1, 20 divided by 2. 5 divided by 1 will get 5, 20 divided by 2 we will get 10. So which is the smallest in number which can be consumed first? 5 is the smallest in number which can act as a limiting reagent. You got it? Then the question, it is given that to calculate the number of moles formed by C in a chemical reaction. So to calculating the number of moles, I am writing this equation, number of moles of A divided by its stochiometry coefficient 1 will be equal to number of moles of B divided by its stochiometry coefficient 2 will be equal to number of moles of C divided by its stochiometry coefficient 1. Okay, so to calculating the number of moles of C, we have to put the equation, this equation and this equation. Why I am selecting this first equation? Because here A is act as the limiting reagent. So for doing that type of a problem, you have to select the limiting reagent moles. That's the basic thing, because the limiting reagent is the consumed first. So for you have to select that limiting reagent of moles. Therefore the reaction will be Na divided by 1 will be equal to N C divided by 1. Okay, the Na, the number of moles of A is given in this question is 5. Therefore 5 equal to Nc. Therefore we will get the number of moles of C is equal to 5. This is the question. So we can do some more problems regarding to limiting reagent and stochiometry. So we do the problems of limiting reagent and stochiometry, and I am giving you a homework to do this problem, that is a plus b gives a2 b3, and try to do from our live section itself. So initially 6 moles of A and 20 moles of B is given you have. So calculate the limiting reagent and number of moles of A2, B3 and number of moles of B. Okay, do it as a homework. And next we are going to a next type of a question. This is also related to some balancing problem. So in a reaction that is 4NH3 5O2 gives 4NO plus 6H2O. This is a question is given. So when 1 mole of ammonia, that's a twisting part in this question. When 1 mole of ammonia and 1 mole of O2 are made to complete the reaction, then what will be the reaction? This is a question is based on your material, that is question number 16. You can check the answers in the question number 16. So I am giving the method how to do this problem. For example, this is a question, it is given 4NH3 plus 5O2 gives 4NO plus 6H2O. Here the number of mole is 4 and the number of moles here is 5. Here the number of moles is 4 itself, and here the number of moles is 6. We have to find the condition when 1 mole of ammonia takes part in a chemical reaction. Here we have 4 mole of ammonia. So I am writing 4 mole of NH3. 4 mole of ammonia we have. 4 mole of NH3 require how much oxygen? 4 mole of NH3 require how much oxygen we have needed here? 5 mole is needed here. So for 4 mole of NH3 we need 5 mole of oxygen. So I am writing 5 mole of oxygen. For 4 moles of reaction or 4 moles of ammonia, we have 5 moles of oxygen. We have to find 1 mole of ammonia. How can we convert this 4 mole into 5 mole? I am dividing this reaction in the left side and right side divided by 4. So I am dividing this whole reaction by 4. I am getting 1 mole of ammonia. 1 mole of ammonia require 5 by 4. It will be 5 divided by 4. 5 by 4 mole of oxygen. 5 by 4 will be equal to 1.25 mole. We will get 1.25 mole. So it will consume the full oxygen. We have only 1 mole of oxygen. So it consumed more than that of 1 mole of oxygen, that is it consumed 1.25 mole of oxygen. That's the condition. Is that clear? The same way we can find the ammonia itself. Just look at into it. How much mole of oxygen is here? 5 mole of oxygen. So I am writing here the values. So if there is 5 moles of oxygen require 5 moles of oxygen require how many moles of ammonia? We need 4 moles of ammonia. So we need 4 moles of ammonia, 4 moles of NH3. Then what about how we have to make it is 1 mole of O2. Therefore how to consider? Divided by 5. So we will get 1 mole of oxygen require 4 divided by 5 moles of NH3. It will be equal to 0.8 moles. 0.8 moles. So approximately it will be 1 mole. Okay, so the 1 mole of ammonia approximately it is consuming. So in this reaction we can say that the full oxygen is consuming in this reaction. So we can do the rest of the problems in our live section.
Bright Education Center, Medical and Engineering Entrance Coaching Center, Hilal area, Doha, Qatar. For further enquiries, contact 306000679.